Welcome, everyone, and thank you for joining us in these very interesting times for a virtual discussion today on future vertical lift. It's one of the modernization priorities for the U.S. Army, and our soldiers and the entire Lockheed Martin team is committed to. My name is Jay Macklin, and I'm the BD Director for Future Vertical Lift here at Sikorsky Lockheed Martin. I'm a retired Army colonel and a proud former pilot of the iconic UH-60 Blackhawk. We're very excited to talk to you today about our entry into the Future Attack Reconnaissance Aircraft program. And we'll also be talking about the U.S. Army's focus to maintain aviation overmatch on the MDO battlefield and the revolutionary leap required in weapon system capabilities to win that fight. We're committed to supporting the Army and its soldiers with, as General Rugen always says, transformational capability. We're going to spend the next 30 minutes talking about the Lockheed Martin team's approach to the U.S. Army's Future Attack Reconnaissance Aircraft, or is known as FARA, and how we're optimizing our RAIDER X aircraft to integrate our X2 technology with state-of-the-art open mission system, providing decades of future capabilities growth and relevance by increasing FARA's reach, survivability, and lethality. We're pleased to have a great panel of experts that can draw on their experience and expertise to make this vision a reality. I'm going to ask my teammates here to provide a short intro of themselves, and then we'll jump straight into the discussion. For intros, we're going to start with Kevin Magnum, then Pete Germanowski, then Christian Corey, then Dina Halverson. Kevin?
Good morning. Hi, I'm Kevin Mangum. I had the honor and privilege of serving in the company of heroes as an Army aviator, flying above the best for 35 years. I retired in 2017 as the commanding general of Training and Doctrine Command. I'm currently a vice president for business development and Lockheed Martin's Rotary and Mission Systems. I'll be followed by Pete.
Hey, thanks, Kevin. I'm Pete Germanowski. I'm the lead engineer for the RAIDER X, and I have the overall responsibility for the technical capability of the design. I'm really privileged to work with a great team of engineers to ensure that our design meets its overall performance, reliability, sustainability, and affordability goals. And we get to work every day using our digital thread and virtual prototype models to bring this design to life.
Hi, how are you? My name is Christian Corey. I'm one of the experimental test pilots down here in West Palm Beach, Florida at Sikorsky's Development Flight Test Center. And I have the privilege of being the lead test pilot on the RAIDER X program.
Good morning. My name is Dina Halverson, and I'm very happy to be here to talk about our sustainment solution for FARA. I have over 20 years of rotary wing experience at Lockheed Martin. I'm very excited about the transformational sustainment technologies we are offering the Army on this program, and how they can shift the paradigm to provide increased readiness at lower cost.
Kevin, as a Master Army aviator with a significant amount of operational experience, as well as former commander of the U.S. Army Aviation Center of Excellence at Fort Rucker, how have you seen Army aviation changing, and what do you see going forward?
Thanks for kicking things off with a great question, Jay. When I started flying Blackhawks 35 years ago, the Blackhawk was the latest and greatest, the best thing since sliced bread, the best assault and utility helicopter in the world. But it was focused on yesterday's threat. It was focused on the threat, the environment, and the warfighting doctrine of the day, which was air-land battle. The threat has changed, the environment has changed. As we fast forward to today, our Army is focused on transforming as a priority and with urgency to a multi-domain operation ready and then capable force between now and 2035 in order to fight and win against near-peer adversaries. Army aviation is going to be required to bring a transformational capability, next-generation game-changing capability to the fight to be able to fight and win in that environment. Having led the first air assault mission in Afghanistan nearly 20 years ago, and having been in the room where the initial multi-domain operation concept happened, it's clear to me that Army aviation commanders and crews will need to be able to see farther, shoot farther. They need to have a greater situational understanding of the battlefield. They need to be able to connect to joint all-domain capabilities. They need to fly faster and lower to survive and win in the future fight. The area of operations will be larger, the tempo will be faster, and connected systems will be required in that battle space to be successful. Yesterday's technology just won't cut it. What we'll need to field is an MDO capable airplane that has the ability to grow with the mission and with the threat.
Yeah, interesting comment about today's capability won't cut it, Kevin. So really, from a warfighter's perspective, why do you think the FARA concept is so important to the Army's warfighting concept?
Multi-domain operations are all about presenting our enemy with multiple dilemmas to increase the complexity of their fight so that we can gain an advantage. So it's using multiple capabilities from multiple domains in multiple directions. FARA is going to be integral to that fight as one of the key dilemmas and capabilities that we can present to increase the complexity of our adversaries, of the adversary's fight. FARA will provide the Army reconnaissance, surveillance, target acquisition from extended standoff ranges and synchronize with long-range precision fires and other joint all-domain capabilities, whether they be cyber, whether they be air, ground, or space. FARA will be a key tool for the Army to penetrate, disintegrate, and exploit those gains to gain that advantage with the enemy.
Yeah, so I know the Army is moving forward, developing its MDO concept. So can you talk to us a little bit about what do you think RAIDER X is going to bring to that MDO warfight?
RAIDER X is purpose built to fight and win on the MDO battlefield. It'll fill that current reconnaissance attack helicopter gap. It'll provide the Army nearly twice the speed, twice the range, twice the maneuverability, twice the survivability with an acoustic signature that's about half of our current aircraft. Those capabilities will be game changing, along with autonomy, fly-by-wire, and our coaxial design will allow our crews to fly extremely fast, extremely low, not only to survive, but to operate in and dominate the lower tier of the air domain and make the lower tier of the air domain decisive. But it's not just about the aircraft. It's a holistic capability. It's connectivity, it's mission systems, it's sensors, it's weapons, it's open architecture, and it's sustainment. Fusing on and off-board systems to be able to provide the lethality that's necessary on the other end. RAIDER X and FARA will also act as a flying forward sensor that will contribute to and enrich the larger intelligence picture and common operating picture across the area of operations. This is about one fused integrated picture for the commander and operators prosecuting the mission. I love flying the Great Black Hawk, but in the future, our nation, our Army, and our fighting aviators will need next generation capability to fight next generation adversaries. A single rotor helicopter is a legacy configuration that's now at the ragged edge of its capability with no room for growth. FARA must be transformational from the outset, and it must have the ability and capacity to grow with the threat and the mission to ensure that our commanders and our soldiers have what they need into the future for the MDO ready force.
So if the Army's multi-domain operations is really kind of like the Army's contribution to joint all-domain operations. So again, when you talk about space, high altitude, low altitude, ground, I mean it gets pretty complicated. And I know Lockheed Martin flying the F-35 today. Can you talk a little bit about what Lockheed Martin brings to joint all-domain operations?
Thanks, Jay. Joint all-domain operations and multi-domain operations is really what Lockheed Martin does. We don't just build platforms or aircraft. We build battle management systems and develop architectures and the means to connect those platforms and capabilities seamlessly across the theater. So we just don't build the dots. We also connect them. We've invested for decades in joint all-domain operations, whether that be, again, in battle management systems or fifth-generation aircraft or maritime systems. And we've invested about $1 billion in X2 technology for the future of rotorcraft. So we build the platform, we build the ability to connect all of that, and we've invested for this purpose-built Future Attack Reconnaissance Aircraft for this very purpose of multi-domain operations.
Okay, thanks, Kevin. That's a good transition. So let's talk to the guy that's designing this thing. So Pete, you're the lead engineer. Talk to us about the transformational capabilities that define the Raider X design.
Sure, Jay. Thanks for the question. In the race to gain and maintain overmatch on the MDO battlefield, we recognize that our soldiers need a revolutionary leap in weapon systems capabilities. And an incremental improvement with a legacy aircraft configuration that is at the limit of its capability just isn't going to get the job done. As we've been flying our S-97 Raider prototype aircraft, we've been experimenting with this leap ahead capability, and we're taking that knowledge base and applying it to our Raider X design. We're really, with Raider X, it's exciting because we're taking X2 technology, which breaks down traditional barriers for rotorcraft speed and maneuverability, and now we're combining it with an open mission system and a digital backbone to provide that connected nodal presence on the battlefield for our soldiers. We're fully leveraging our digital thread and virtual prototyping tools to maximize the capability of our design and to optimize our design's affordability and sustainability across its life cycle. And these tools are really physics-based tools. They're informed by our S-97 prototype. They provide us with early discovery, they minimize redesign, and they enable future upgrades to be efficient. So it's really exciting to bring that tool set to bear on Raider X. And with Raider X, the capability that we're providing is designed for superior reach, survivability and lethality, and lower life cycle cost. If the Army's going to win against near-peer threats, our soldiers need these capabilities, need these systems, and these systems need to be able to grow over time to support the evolving needs on the battlefield. Yesterday's technology just won't cut it.
Yeah, interesting. You talk about growth. Obviously, 2030, these aircraft are going to be out, on the battlefield. And give, to be able to get that edge, it seems like growth needs to be built in. Can you talk to us a little about the growth capability that Raider X you think is going to give the Army?
Yeah, I agree with you, Jay. And we really embrace the need to design growth into the platform up front. We've architected Raider X so that it can incorporate growth in the ITE engine power immediately. And we can use that growth to increase our speed, our lift, and our maneuverability. We've also designed growth into the platform in terms of the mission systems and sensors. We have an open systems architecture to allow rapid and flexible changes to our hardware and software. And we have a digital backbone to enable rapid integration of advanced capabilities. The last thing that we did, thinking about growth in the design, is we provided Raider X with a large internal weapons bay capacity. And that bay, it enables the Army to carry a diverse range of munitions that are available today. And it also enables the Army to develop new munitions and new ALEs to support the future needs on the battlefield without constraining the size and packaging of those munitions.
Okay. Thanks, Pete. Most people are familiar with the S-97 Raider. It's obviously been flying for years down our West Palm Beach test flight facility. Interesting. Can you talk a little bit about the synergy between the S-97 Raider and the Raider X? What's the linkage there?
Yeah, it's interesting. We've now demonstrated X2 technology across a wide breadth of aircraft sizes, as small as 5,000 pounds and as large as over 30,000 pounds. And the S-97 Raider and Raider X kind of fall right in the middle of that spectrum. The S-97 Raider is an 80% scale prototype of Raider X. So it really informs our design with flight test data. And every time we send Christian out to fly the S-97 Raider, we collect flight test data that informs, the question of the day on Raider X. Be it performance or flight loads or maneuverability and agility, we're really able to experiment in real time as we're making decisions towards ultimately the capability that we're going to provide to the warfighter. The data is invaluable and the timeliness of it can't be understated. The other thing that the S-97 allows us to do is we can take that flight test data and we can use it to improve our virtual prototype models. Our design fidelity is really increasing on a daily basis every time we fly that aircraft.
Yeah, no, it's a perfect transition, Pete. Agreed. Invaluable what the S-97 is bringing to the FARA program. Definitely. So thanks, Pete. So let's go over to the guy that's got the job that we all wish we had. So Christian, you're the guy that gets to go out there and fly, Raider. So as a lead test pilot on the FARA program, tell us about your experiences flying the aircraft and kind of expanding that speed maneuverability envelopes.
Yeah, Jay, really, thanks so much for letting me participate in the panel here. Really excited to tell the story of what we're doing. And I think as we describe Raider X and the path ahead, certainly, exciting times in the vertical lift business. But I think it's important to take a look real quick at how we got here. You don't just wake up one day and decide that you're going to, transform the state of the art. And fortunately, back in the early 2000s, my predecessors at Sikorsky got together and decided they wanted to push the envelope and try to figure out just how fast could they make a helicopter go. And they set about doing that with this counter-rotating coaxial rotor design with a pusher prop. And they built the X2 technology demonstrator, and in fact they were able to prove that they could sustain flight at speeds previously not really seen in helicopters. And so the next logical step out of that was to try to package that in a way that demonstrated an operational relevance to that capability, and thus was born the S-97 Raider. And so we've been flying her for just 5 years now, and have continued through that time to expand, the envelope of what is considered normal for a helicopter to do as we look to the future and try to transform what is the state of the art, I suppose.
So I guess Raider moves, and becomes FARA. Talk a little bit about your thoughts on that.
Yeah, absolutely. It was just a year ago that we unveiled the Raider X, and that is our submission for the Army's Future Attack and Reconnaissance Aircraft program. Just another step in the journey for us, really. It was an ability to take what we had done in the Raider that we're super happy with everything that we're seeing there. But when you build a machine like that and you fly it around, you're obviously left to think, boy, next time it should be great if we could do X, Y, or Z. And it turns out that Raider X and the FARA program are exactly that opportunity. So there are tangible lessons learned in Raider that we're able to carry forward and say, you know what, this is our chance to do that better. And so we're already on the next iteration that the Army is going to be able to take advantage of those lessons learned over the past 5 years. And Pete said it, when we go out and we fly Raider, it's to answer some question that he and either the design team have or the modeling and simulation team. They're trying to get to what is the right way to make this thing better. And what better way to do that than to go out and actually fly and generate real flight test data and be able to feed that back into to your process in real time. So when it comes to transforming, I just don't know where we'd be if we hadn't started this journey quite a while ago. So pretty glad for the position that we're in now with respect to that.
Absolutely. So you're a career aviator. You've flown helicopters into harm's way in defense of our great country. So having flown Raider and soon Raider X, how do you expect the Army's going to receive it?
Sure. I think there's a couple of things when you talk about a military machine that come to mind. Speed, range, maneuverability, and lethality are probably at the top of my list. But I'd be remiss if I didn't say that thing ought to be easy to fly too. Particularly as we look at the emerging threats in the battlefield of the future. It's not going to be what we've been doing for the last 20 years. So it's going to require every bit of the crew's ability to show up in an objective area armed with as much situational awareness as they can possibly have. So, Kevin, went on about, the integrated battlefield, and really that's what we're building here. It's a holistic platform. It's not just about how fast can you go and how far can you go anymore, but it's how much can you truly integrate into the common operating picture, and we feel strongly that's where Raider X is going to take us as the future unfolds.
Yeah, absolutely, Christian. So, interesting, one of the aspects we really considered one of the transformational aspects of the X2 technology is a propulsor. And you know, the ability to, you know, level body acceleration, deceleration, and the maneuverability that very unique characteristic enables this aircraft is really beyond anything that's out there flying today. It's featured on both Raider and Defiant, our FARA and FLRAA technology demonstrators. And you're one of the very few people in the world flying it. So, you know, what do you think this propulsor gives to a pilot flying the FARA mission?
Yeah, you know, the propulsor really is, I think, the sort of bread and butter of the technology. When you look at it, once we engage that and we push out to forward flight at higher speeds, the propulsor is what generates the thrust, and it really allows the coaxial rotors to simply generate lift. And so in that, it truly is a rotor wing platform. But it offers frankly, another dimension of capability. And at this point, I hate to say, it's almost one that I take for granted. I've just come to know to fly it. But, you know, we had an opportunity not too long ago to fly an Army test pilot, and he remarked throughout the course of both the preparation for the event and the event itself that, wow, that propulsor really gives you a whole other degree of freedom. And it's true. I think it's really going to allow the Army to change the way they write their tactics, techniques, and procedures, and are able to employ these aircraft in pursuit of the mission. You know, and a real world example I would give you, a couple actually. When we talk about the propulsor, it has the ability to thrust, but you can also disengage it. And in so doing, not only do you change the manner in which you fly the aircraft, but really you're able to change the acoustic signature. And so right away, you've got sort of a tactical advantage there that you can sort of make the aircraft quieter than it was before. But the other advantage of that, if you think about it, is that propulsor sitting on the back of the machine is not a flight critical piece of equipment the way a tail rotor has been on conventional single main rotor helicopters. So from a survivability standpoint, that's a real big vulnerability that we're able to hopefully eliminate in the design as we go forward. But operationally, I would tell you that propulsor, you know, there's nothing like the feeling of putting yourself into sort of a gun run profile and find the nose pointed 20 degrees down and put maximum, you know, negative thrust out of that prop, and the airspeed simply doesn't change as you're in that dive. So that translates to just more time on target as far as your ability to keep the nose trained on whomever it is that you're intent on keeping the head down. And then as you exit that maneuver, you can reverse the prop, begin to generate that thrust again, and then set up for the next ensuing attack, I think, in a whole different way than you could before. So those are just a couple of examples of the way I think the Army is going to be able to really utilize the capability that we're going to give them here going forward.
Yeah, absolutely, Christian. And you just described, you know, transformational capability. You know, I think it's going to change the way, you know, fundamentally how our aircrews of the future are going to fight. So thanks for your insights, Christian.
You bet, Jay. Thank
really
you.
interesting. Spo, so we go now to Dina, and she's our sustainment director. And we all understand that combat power is generated through maintenance and sustainment. So we can't go out and, you know, make everything work unless, you know, we're able to sustain it. And I know from the beginning of this design, you know, what Pete, from the very beginning, sustainment was designed into this thing with you know, the maintainer in mind. So Dina, you know, not that you're the last person we're talking to, because this is of the utmost importance. So tell us about Lockheed Martin's sustainment approach to FPL in general, and what makes you know, this approach different.
Yeah, thanks, Jay. Again, really excited to be here and to talk about our sustainment solution for FPL. So that solution is really focused on increasing availability, improving reliability, and ultimately lowering the life cycle cost of our Raider X platform. As Jay said, this aircraft has been designed for sustainment from the very beginning, with a focus on reliability improvements on critical components and overall design simplification. The best design is a simple design. It lowers the number of parts and therefore the number of possible failures. In addition, each tail number will have a digital twin or a digital model, and we will use advanced analytics, artificial intelligence, and digital tools to collect, monitor, and analyze on and off-board data to keep those components on the aircraft longer and reduce the overall maintenance burden. Just like Raider X is built off years of X2 technology and is relatively mature, our sustainment solution is built off 2 decades of technology investment in analytics, prognostics, and advanced manufacturing. And we have seen the success of those investments, increasing availability of our commercial fleet and a significant reduction in the maintenance burden on our 53K aircraft as compared to its predecessor. For RAIDER X, this means we can leverage over 100 predictive maintenance algorithms that Lockheed Martin has already developed, as well as onboard maintenance diagnostics and prognostics that really create a paradigm shift, both by increasing global readiness and also by enabling limited or maintenance-free operating periods that will be critical in an MDO, what will be a critical MDO capability. For FARA, we will use these algorithms and the data from sensors on the aircraft to enhance that digital model over time and to create a digital twin that is continuously updated to reflect the aircraft's true condition once in use. This means that crews can more accurately track what the rotorcraft actually goes through during its missions, the loads it carries, the vibrations it experiences, extending the life of the components on the aircraft if they experience less than typical wear and tear. It also enables predictive maintenance, allowing maintenance teams to track when a component might be ready for overhaul at a future date, allowing crews to conduct maintenance on their own terms and driven by mission requirements. We are very proud of our more than 40 years of partnership with the Army on sustaining their Black Hawk fleet. We work every day with AMCOM, PEO Aviation, DLA, Corpus Christi Army Depot on supply availability and reducing back orders to the fleet. This includes a strong public-private partnership with CCAD, where we are investing in developing additional critical organic sustainment in support of the Army. We are also excited to be working with AMCOM and Wichita State on a digital twin for the Lima model Black Hawk as we continue to mature this technology. We also realize that advanced manufacturing techniques, including additive manufacturing, will be critical to reducing lead times and getting parts more quickly to the point of need. Lockheed Martin has world-class additive manufacturing capability, and we are already working with the DoD and the Army on further developing this capability. I look forward to more collaboration in this area as we bring this transformational capability to the warfighter on both FARA and the Enduring Fleet.
Thanks for a great summary of Sikorsky and Lockheed Martin's sustainment technology, capability, and concept. And it's going to be certainly going to be important in the future. FARA must be maintainable and sustainable to allow commanders and soldiers to launch, recover, and launch again at a rapid tempo in austere environments for extended periods of time. And reducing the operating and sustainment costs is key to making Army aviation as effective and as efficient as it can be. Lockheed Martin is committed to doing just that, providing soldiers with game-changing transformational capability that's both affordable and sustainable. I'll turn it over to Jay to close us out. See y'all on the high ground.
Thanks, Dean and Kevin. And I want to really say thank you to all of our panelists for the fantastic discussion. As you can tell, we here at Lockheed Martin are very passionate about what we do, and we're very excited, working very closely with our Army partners in moving forward and providing this next generation transformational capability to the Army, because we certainly understand how important this is and what's at stake. This has to be right, and we're committed to it. So again, we'd love to keep talking, but it looks like we're out of time. So if you have any questions, feel free to email me directly at j.r.macklin@lmco.com. Thanks a lot.